So next up, we have Team 5, the scanner Siim-ulator, and it is an entirely, the team is virtual. So who is presenting on behalf of that team?
Hello, I'll be presenting. This is Ben from...
Great, thanks, Ben.
Okay, I'll share my video and... Okay, hi everyone. This is I'm Ben from Ben Park from Circle Cardiovascular Imaging. I did this project with Mike Ross from Q.
We can't see your screen if you're sharing.
Oh.
Here it comes. Yep,
yeah,
there, now
yeah.
we can see it.
Sorry about that. Okay, let me... Okay, yeah, I'll go ahead. So the project for this hackathon is a scanner simulator, and the purpose is we want to use the simulator for software performance testing. I'll proceed. Okay, so from a vendor's perspective, we build cardiac post-processing software for MRI and CT. And some of the common challenges that we had when we're ingesting DICOM images is these four. So whenever we import images, we have to group them, we have to sort them, and we have to do that all without interrupting user workflow. And especially for cardiac MRCT, you have like multiple series and slices distributed across like original series. And so you need to like combine them, sometimes split them. And it gets even more complicated with these 2D 4D flow sequences. And also for performance, we also have challenges during peak hours when there's very high load. And we also need to ensure stability over extended periods of time, which means that the software works well for like 2-3 months and then suddenly it breaks. So those sort of testing, we have to establish like the process for that. And also for ensuring endurance when ingesting studies randomly in random order, random magnitude. So these are all challenges that we have when it comes to software performance testing. So to improve software robustness, what we do now is we normally test the happy path. So we deal with full, complete studies. So we import the study, and then we make sure that all the values are correct as per our test data results. And then for performance, we always deal with like regular predictable study load in a specific order, but that has some limitations. So we think that it's not enough. So we have to test not the happy path, but all these different scenarios where it really happens in the actual environment. We need to load partially ingested studies when studies are coming in. The order can be different. And in peak hours, extreme load, of course, and also stretching out these testing scenarios into days and like weeks even. So in order to do this, I implemented a scanner simulator, and I'll show you a live demo of how this looks like. Okay, so here. So this is it. Yeah, so this is it. It's a very simple UI. So what you'll see here is a job. So this means that, let's say if you went to the scan room, this means that your MRI machine is just waiting to send to this A title. So for this app, it is currently listening to DICOM on A title default SCP and port 11112. And you can kind of, I'll just give a brief test so that I'm sending images, and then you'll see that whenever you're receiving images, it gives a notification. And then with these studies ingested, what we want to do is we want to have multiple jobs that you can run simultaneously. So I'm going to create a new job here. A job means that you're sending, you choose a sender. So I'm gonna send like from a CT, for example, to a destination like or think that I have on my system. And then I can choose some studies here. So I'll choose this one because it has the lowest size, the small size data set. And then let's say that I'm just going to send this one study. I can name the job. I can, if I'm gonna, I can adjust the send study interval if it's going to be multiple studies, but I can set that to 0 for here. And if this has multiple series inside, I can set the interval for that too. Like for each series, wait 1 minute and then proceed with the next one. You can also replace these UIDs, replace PHI, and you can loop for hours. But let's say I just want to send this once. And I'll add a job here. And you'll see that now I have a new job called SEMCT. So what I'll do is I'll try sending this to Orthink. And here you see that it's sending the study sim gene from the sim dataset. And this is my Orthink. And you'll see that it's like coming in here. And at the same time, I'm also going to send a bunch of MRI studies looping to my product, CVI42. So if I just play that, the system is going to run multiple jobs. And you can check that here by, this is our CVI42 product, and you'll see that images are coming in. I'm replacing UID every time. So it's the same patient, but you'll see that I'm able to import because they're considered unique studies. It's also to mention.
We're at time. If we just wanted to, 1 or 2 more sentences.
Okay. Yeah. I'll just head back to the slide then. Okay. So what's next? I had some requests for open sourcing this one. So I open sourced this project at GitHub. You can check it out in this URL. And then more features to be added. Scheduling is under construction, under development, and we also need to accommodate all these different modalities, transfer syntax, enabling TLS, and deployment strategies, and on and on.
Great.
Yeah,
Thank you very much.
Any questions?
Yeah. One question from the judges. Kevin.
Yeah, well done for tackling the non-happy path. That's really important for robust systems. I was wondering, were you doing all of this with the single frame IODs, or did you use also the multi-frame enhanced? And if so, how would you also, for example, try changing how the slice groupings were packaged into the enhanced objects?
Yeah, so I guess from this app's perspective, enhanced will be just larger file size. We group those inside our application after importing when we load the study. So that's kind of out of the scope for this the simulator.
Okay.
Yeah. Okay.
Great.
Thanks.
Okay. Thank you very much. Team 5, Scanner Simulator.
Thank you.